Hey guys, welcome back. Now let's get started with our day 21 walkthrough. So you guys can read the story here. So coming to the learning objectives, understand how larger CI/CD environment operates, explore indirect poison pipeline execution and how it can be used to exploit Git, apply CI/CD exploitation knowledge to the larger CI/CD environment. CI/CD environment. Often, developers or other end users only see a limited portion of the CI/CD pipeline. Developers interact with Git on a daily basis, so it makes sense that the CI/CD is most commonly associated with Git. Although it only makes up a quarter of a typical CI/CD pipeline, the diagram below visualizes the general segments of a pipeline: development, build, testing, and deployment. While these segments could be expanded and interchanged, all the pipelines will follow a similar order. In the previous task, we looked at CI/CD environment that was self-contained in Git. In a more formal environment, segments of the pipeline may be separated out onto different platforms. Below is a CI/CD environment we'll be exploring in this room. You will notice the addition of Jenkins, a build platform and automation server. In the next section, we will explore Jenkins and discuss how the components interact and contribute to the pipeline. Jenkins, along with many other applications, handle a pipeline's build segment. These platforms can be remote or local. For example, Travis CI is a remote build platform, whereas Jenkins is a local automation server. These platforms rely on runners or agents to build a project on a pre-configured VM. One advantage of some automation platforms is that they can automatically create and configure build environments on demand. This allows building and testing in different environments without manual configuration or administration. Indirect poison pipeline execution. Let's briefly shift our focus back to the development stage. In the previous task, poison pipeline execution was introduced, wherein an attacker has direct write access to a repository pipeline. If an attacker doesn't have a direct write access, it's possible they have write access to other repositories that could indirectly modify the behavior of the pipeline execution. If an environment is employing a development pipeline, a configuration file must be defined for the steps the build system must take. If a repository contains all necessary source and build files, and another repository contains the pipeline files, write permissions could differ between the two, resulting in an indirect PPE vulnerability. In this example, you can assume that the repository containing the source is not write protected, and the repository containing the pipeline is write protected. To exploit this vulnerability, an attacker would need to identify a file or other parameter they can arbitrarily change that the pipeline file will use. Make files and other build files are usually exploitable because they are used to build the source and can run any arbitrary commands as defined in the make file. Below is an example of what it might look like in the pipeline file. To weaponize this vulnerability or PPE in general, the CI/CD environment as a whole must be taken into consideration. For example, if a build server is used to build artifacts on a pre-configuration virtual machine, an attacker could run arbitrary commands in that environment. Practical challenge. Now let's apply what we have learned in this task to Antarcticraft's CI/CD pipeline. So now let's go and fire up a machine. So navigate here, the Git platform Antarcticraft's used for version control and development. Log in using the credentials, guest and password 123. When you have logged in successfully, you should see two repositories, gift wrapper and gift wrapper pipeline. Then navigate to this other link, the Jenkins platform Antarcticraft uses for building and automation. Log in using the credentials admin. Once you have logged in successfully, you should see a project gift wrapper build. Before looking at the environment's other components, let's dig deeper into Git repositories. Okay, so now let's copy this. So here we have the two repositories. Let's go into this. So now let's copy this link. Looking at the gift wrapper pipeline repository, you may notice a Jenkins file. If a repository is unprotected, an attacker can modify the pipeline file to execute commands on the build system. For example, an attacker could control the build stage by modifying the make true to who am I. This is possible because the Jenkins file allows you to run shell commands, as you can see on line 13. To modify Jenkins file, we will use the power of Git. To begin working with a repository, a local copy must be created or cloned from the remote repository. In this example, git t. Run the command below to clone the gift wrapper pipeline repository locally. Okay, so let's copy this. Now let's open up a terminal. Now let's make a directory and clone it inside it. So now to edit this file, let's use nano. So now let's change this to who am I. When a commit is created, a snapshot of the current state of the project is saved to the local repository. To add our changes to the remote repository, we must push our commits. After modifying the Jenkins file, run the commands below to add, commit, and push your changes. Now let's enter the username and password. When attempting to push changes to the repositories, you'll notice that it is main protected. You can also try creating a new branch, but you'll notice that the repository is branch protected too. This means we must find another way to indirectly modify the pipeline. So here we can see the user permission is denied for writing. Looking at how the Jenkins file works, you may notice that it uses make. If you recall from the previous section, a makefile can be used to define a set of rules to execute steps, such as commands. The makefile is defined in the gift wrapper repository, meaning it could have different protections than the pipeline repository. An attacker could add malicious commands to it. After also cloning and attempting to push the changes to the gift wrapper repository, we see that our commit is successful. Depending upon the configuration of the build system, different actions may initiate new build. In this example, we have access to Jenkins, so a build can be manually scheduled by pressing the green play button. So earlier we had cloned this repository, now let's clone the other one. So here we can see the makefile. So this makefile here is able to run this command. So let's go and modify the makefile. So here we have the play button. Let's click on it. So once our build is complete, let's go to the latest build. Now let's go to the console output. So here we can see we got the answer for who am I, which is Jenkins. Okay, so now let's go to the questions. What Linux kernel version is the Jenkins node? So now to get the Linux kernel version, let's use the uname command. So now let's click on the green button here. So if you notice here it shows the message we put in the commit command. And now let's go to the console output. So here you can see a kernel version. Let's copy this. Coming to the second question, what value is found from this location? So let's go back. Let's use the cat command to read it. So now let's click on the play button again. So here we have the value of the file. Let's copy it. So now we have successfully completed our day 21 walkthrough. Thank you for watching my video and stay tuned for more.